Thank you, everybody, for having me today. I'm excited to talk to you about the future of mobility as Bell sees it. Yeah, great. And really, it's a story about our past first. Bell always likes to talk about our legacy of innovation, that legacy that's going to carry us forward. So if you think about how we use the things that we've learned in the past, a couple examples come to mind. I'm sure a lot of you are talking about the 525 today. It's going to be the first commercially certified fly-by-wire aircraft. Fly-by-wire is one of our fundamental strengths, and we use it from our legacy and bring it into the future. We also have a legacy, as you see here, of powered lift aircraft, which are really the core technologies and the core designs for the future of e-mobility. We need to have powered lift because it's batteries and motors now for these vehicles that they want to do a shorter mission with a little less payload, but those are still heavy. Those are still inefficient and relative to the traditional propulsion options that we have. And so powered lift helps us get on wing, get efficient, and get the mission done. So I'd like to start with a definition for us of mobility itself and on-demand coupled with it. I think the world is changing in such a way that on-demand is in every part of our life, whether it's moving around or buying goods for the family. And we look at that as simply whenever you need it, wherever you need it. And mobility, and particularly mobility as a service, we look at as not only moving freely and easily from point A to point B, but we ask ourselves a bigger why question. Could new mobility forms, new mobility modes help with that second definition, where we know that economic success, success in society, choices about where you live, where you work, are actually linked very heavily to mobility. So if we can come up with a mobility platform that can reach the everyday consumer, reach the everyday commuter, then I think they can start to move into that second part of the mobility definition. If you think about moving goods around in the same way, although that's more of a business arrangement rather than a personal one, you can imagine how it would affect you in your personal life, where suddenly it feels great right now that all the SKUs that can arrive in 2 hours to your front door, but maybe there's a whole nother list that folks that do logistics are thinking about bringing to you in a faster way, and we'd love to be a part of that. So Bell has a top-level strategy about how we win on programs like air taxi and unmanned logistics support. And it's one of my favorite slides and one of the least favorite for my engineers. Technology demonstrators are easy. We're looking to create a viable, certifiable system to address the market. And so you don't see Bell out there with their demonstrator yet. You see us doing full-scale and subscale testing at the wind tunnel for key system features on our aircraft so that we know we're integrating the best technology that we can have available at the time and certification, and the infrastructure, maybe more importantly, is ready for vehicles of this kind. We also look at this mobility ecosystem as needing to be integrated around 4 frameworks encompassed in an innovative business model. So it's really easy to have a talk like this about the technology because it's the sexiest part and you get great videos and great graphics for new types of configurations and technologies. But we believe there's harder bits out in front. So I'd like to show you those frameworks here. And really we think this is about the right order. And the first thing you notice is that the technology is at the end of the list. And the reason we do that is because if you put a bunch of great engineers in the room and the physics work, they'll figure out the technology part. But with this new system of on-demand vertical mobility, we need to think about the operational framework, How do they fly? Where do they fly? How crowded or not is the airspace? Where are the corridors that we can fly in? We have to think about the regulatory piece. The last time I checked on all the eVTOL vehicles that I've seen, it's new tech from top to bottom, not only from the propulsion standpoint, but also from autonomy, and really the integration now of the control effectors and the propulsion effectors being distributed around the aircraft. And also on the regulatory side, how do we fit into communities that need these aircraft? What kind of local laws do we need to deal with around noise or integration into the physical infrastructure mobility system there? Manufacturing is another big piece. If you think about your helicopter or even our tilt rotor business today, we see that our manufacturing facilities, although a great foundation, aren't exactly set up for the rate that we expect in the eVTOL space. They're not set up for the technology. So we need to start thinking about those things in parallel, but maybe even ahead of the technology piece. So then that business model. I've put up a slide here that talks about the available verticals in this space of on-demand mobility as a service. And if you look here, you can pick out where Bell lives today. We're an OEM, so of course we live in the air vehicle column. We also support flight operations and maintenance operations through our training programs, but we don't perform flight operations or maintenance operations for our customers. But those are questions maybe that we need to ask ourselves, given the newness, the uniqueness, the novelness of this new emerging market. In the middle, you see the digital infrastructure. Well, if it's going to be on demand and going to have a ready rate that's different than what we're used to today, you have to have a digital backbone in place to make sure your customers can arrive as quickly and efficiently as possible to the starting point of an eVTOL flight, or have unmanned logistics vehicles, for example, ready at any time and stationed to take goods from one point to another. That digital infrastructure extends all the way from the booking engine to that final flight that the customer takes. It also extends into your core business. So we're very interested in looking at that. I'll show you a product that we're working on in that space. Now the physical infrastructure, we're not real estate folks, but you'll notice a couple things on the list there where you need to tightly and closely work with the folks that are thinking about physical infrastructure. These are essentially Internet of Things objects, more complex than the others that we've seen in the past, but they're going to connect to the physical infrastructure. It's not just about, well, do you have a platform that can take the weight? Do you have the safety systems that support? Now it's about charging systems and the grid in your community. It's about new types of communication and ground-based infrastructure to help you fly in a more safe way. It's about mobility centers that not only have a bus or a train stop in it, but a place where our community can come and live and thrive and then move easily about. So on the operational side, we introduced AROS this year at CES. This is our aerospace operating system, and it's meant to help us or our customers think about intelligent scheduling, think about the visibility that they need during the operations so that you know when maintenance actions have to take place ahead of time. You know when you need your parts and your spares. You know, in the electric VTOL case, what vehicle should stay on a certain route. You can imagine how, with batteries, if you run one vehicle, let's call it ship 50, 60 miles at its maximum range all the time, well, that battery life as the main propulsive unit is going to change relative to another vehicle that flies 20 miles a day. So a system like AROS is required to do that fleet management in a smarter way that even involves placing different assets at different nodes on any given day. We're really excited about this product, and what we showed at CES was the master scheduling piece. So if you remember any of the videos, these little Nexus drones were flying around, but they were getting their instructions from the folks that were there at CES as the audience. They were putting in, they were asking certain routes of the vehicles, and they would stack the schedule up and fly autonomously at that smaller scale. We're in a really neat collaboration with Microsoft here. Lest I skip the part where you're saying in your head, wait a minute, Bell's not a software company. We have a friend that's helping us with this, and it's been a really powerful collaboration to date. On the regulatory side, I have a little clip that runs, and so I always remind people that no matter what your vehicle type is, and here we're showing our 6HX from last year, you have to remember it's not just the vehicle that needs to certify, but also the production facilities that you have, and also the airworthiness considerations. We know that in this audience, but oftentimes in this new world of eVTOL, there are startups and other entities that don't remember there's more to it than just certifying the vehicle. We also have to think about the international implications of the regulatory bodies. You see already a little bit of diversity between the FAA approach and the EASA approach, and we'd like to see those two things come together so that we can have efficiency in certification and drive that cost down on the NRE side. And then on manufacturing, and I talked a little bit about it's the factories and they have to be different, but also the processes that you're using have to be different. So already today, we're looking at, well, how do you build an 8-foot duct, a 7-foot duct? What does it take from your composites folks to get that structure as rigid as possible and ready for mass production in the future? And then on the other side, this is one of our UAVs. You'll notice relative to the person there, that's smaller than anything Bell does. So you have to ask yourself that question about, do we do this internally or do we do that externally because of the normal size of the vehicles that we work on? So now let me relate it all back to maybe the spot that you're most interested in. It's the spot that I work in, but I hope other pieces of the framework resonate, and that's the technology. So what we'll show you here is first App 70. This is our offering in the unmanned logistics space. This is a tail-sitting biplane that carries 70 pounds of goods, and it weighs in at about 300 pounds max gross weight. This vehicle takes off vertically, converts its whole body into airplane mode, and it's doing great so far. We just demonstrated for the U.S. Marine Corps out in Yuma, Arizona, carrying 70 pounds for them. It's a vehicle that can go a lot faster than these quadcopters that you see out there, and of course has a lot more range because it gets on the wing. It's also a family of vehicles. So here we show App 70 at 300 pounds, but also App 20, again 20 being the payload. And we're thinking about a vehicle that's even larger than this. So this family can be a part of your logistics solutions. Not so much drop the soccer sneaks off in the backyard, but connect distribution centers, connect storefronts, so that an already efficient logistics network can just offer more to their customers in a more rapid way. The second piece of technology that we talk about is the Nexus 4EX. This is the latest rendition of our air taxi vehicle. It is all electric, and it has 4 ducts rather than 6 that you saw on our hybrid electric version last year. We're targeting 60 miles range, 150 miles an hour cruise speed, and 4 to 5 passengers. And again, the physics look like they're there now. We're taking a shot at it to bring it to certification, and we're really excited about the movement that we've made towards the electrical propulsion. So another shot of Nexus 4EX from the top. And again, we've maintained, people ask us a lot of questions about, oh, you went to 4 ducts, is it still okay? You still have the redundancy. Well, it's all about reliability. It's not really about redundancy. Redundancy is one of the tools that we get reliability. And I'd like to show you this last slide to assure you that the core system values that we think about are still intact no matter what vehicle we're working on the innovation team. So you see here safety, not just the air vehicle, but the flight operations, the maintenance operations. We all know which one of those three really affects global system safety on an air vehicle that does vertical takeoff and landing missions. And so we want to focus on those as well as the vehicle itself. And then accessibility, affordability is underneath there, and it's great to see in our models how electric propulsion changes that equation. So big maintenance items on normal helicopters, hub, transmission, gas turbine. Now that's small, simple hubs, power electronics, and battery packs that you can operate with in a more LRU type way, pulling modules out, putting modules back in. So we're really excited about the affordability on the DOC part. And it also has to be convenient and experiential, because I talked about these reaching that common consumer, that common commuter. Well, if they're not convenient and not experiential, then that's likely not something that's going to be sustainable from the relevance standpoint. And of course, sustainability still remains a core goal. Quietness, noise, that's a part of sustainability to us. And of course, these vehicles with smaller distributed rotors enable us to get the tip speeds down and really change the paradigm around noise. And lastly, cleanliness. So it's a tough one, right? An electric vehicle operates cleanly, greenly, but where did we get the material for the batteries? Where did we get the material for the motors? And then what are we going to do after the life of the batteries has expired for an aerospace opportunity? Can you move it onto the grid? Can you move it onto ground vehicles? So we need to think about that from end to end, the so-called well to wing, and maybe back to the well. So I thank you for your time today, and I'll use the last 5 minutes for any Q&A that you have.
Thanks, very, very interesting. What's the recharging time? You mentioned a 60-mile range, then you come back to base. How long to recharge?
Yeah, so if you're doing that full charge or full discharge for the 60 miles, you're talking about hours, so that's a vehicle that you have to manage the right way. When you're talking about those 20-mile trips, you're just kind of stepping down on your charge cycle. So your first 20-mile trip, you come back, it's a 5 to 10 minute recharge, and then you go out again with that same capability until you've gotten down to, a state of discharge roughly around 80 to 85%. We don't want to ever go too much below that. Maybe in the 60s would be the max. But as long as it's a shorter range, you can stair step it in at those 5 to 10 minute charges. Those full range missions are going to take hours.
Thank you.
Yeah. It's an important question because you got to keep the pace up, bringing people in. You think the speed always fixes everything, but it's actually the connectivity to the other modes, and that plays a big role in it.
Hello, Nigel Watson. Timeline for development, when do you think you hope to get anywhere near certification or passengers?
So Bell lays, given our initial message, we're looking for a fully certifiable system, not just vehicle, but infrastructure. We think it's the late 2020s, so 2028 to 2030. And then, of course, we'll do our demonstration vehicles and prototypes within due time inside of that schedule for support of the technology development.
And does it always have a pilot?
So our plan is our technology demonstrator will be fully autonomous with so that we can hit those points and understand what the autonomy means to the system. We believe that first vehicle that goes out to serve the market has a pilot on board, and then you start to work customer acceptance of not having the pilot with you, and also expanding your mission capability around the certification challenges that'll be involved with autonomy. So pilot first. We call Nexus 4+1, +1 being a little bit cheeky, that's the pilot in the beginning, but once we get to the autonomous state, that +1 becomes a +1 in a revenue paying customer.
And how much is the internet dependent upon the success of this?
Did you say the internet?
The internet, the loss of the internet, the loss of...
Yeah, so we love the idea of 5G being a part of what we do here, but think of it in terms of what it does for our aerospace operating system. So you've got a fast, wide tube to get data down and back to the aircraft so that there's a smooth decision stream for your daily operations. But to think about 5G as a flight critical technology in the loop, we don't think it's ready for that. It would be one of maybe 2 or 3 parts to have a redundant communications and maybe awareness situation, but it would have to be coupled with ground-based radar or onboard sensors or other pieces of the infrastructure.
Thank you.
Yep.
Any more? Final question. There's 200 eVTOL projects in the world, or more than 200. And obviously, they can't all succeed. How much do you estimate it would take cost to start up to go from day one to full FAA certification?
Yeah, we always talk about those numbers as a combination of you got to get the vehicle ready, you've got to get the manufacturing base ready, and you have to do smart things around your operation. So you're talking in the billions, and it's something that it looks like many of those startups are learning this because you see them asking for larger sums. But some, it doesn't seem like they've connected with it yet because they're thinking all of these things make it easier, and in a certain sense, electrification does. But when you get down to the details, it looks like a regular certification program.
Great.